Oh, that's too bad. Okay, so for these, the first thing we always look for is common factors. So with the numbers, we got 18 and 27. What number is the common factor there? 9. For the variables, we always look at the lowest power. So it has to appear in every digit. In this case, x does. It appears in both of them. And the lowest power is just x. So x to the 1, if you want to call it that. So now we're going to divide out the 9x to see what is left over. 18x squared divided by 9x. 18 divided by 9. 2. X squared divided by x is just x. Negative 27x divided by 9x. Negative 27 divided by 9 is negative 3. And x divided by x divides out. So that is 9x times 2x minus 3. For number 2, is there any common factors? No. 1 is the number with the x squared, so there's no common factor for the numbers. And the x does not appear in every digit, so there's no common factor for the variables. So that means we're going to try this reverse multiplication. So that first number in each has to do what? Has to multiply to make what? The x squared. So that's got to be x times x. The second two numbers have to multiply to make 6. So we've either got 1 times 6 or 2 times 3. Since these are just x's, the order that we put these in doesn't matter. Which ones are we going to use? Plus 2 and plus 3. To make sure we got it right, we're going to double check. We're going to do the outside. X times 3 is 3x. We're going to do the inside. 2 times x is 2x. And that does add up to 5x to give us that middle digit. So that is what we want. It is x plus 3, or x plus 2 times x plus 3. Any questions? Is that all coming back to us? Kind of. You want to try a couple more? Okay, let's do that. No problem. Let's try those two quick. So if you look at the first one, there are no common factors. So we're going to try that reverse multiplication again. 3 can't come out of the first one. What's that?
Yeah, but there's not a number in front of x.
There's no number here, so you got to. The number has to divide every digit. So it goes into 3 and the 21, but it doesn't go into 1. Good thinking, though. So yeah, it doesn't divide every term, so we can't do any common factors. So we're going to do the reverse multiplication. Since I just have x here, these both have to be x and x. So x times x makes x squared. The last two have to multiply to make negative 21, which means one has to be positive and one has to be negative. So we're just going to put in positive and negative here quick. Possibilities to multiply to make 21 are 1 and 21 and 3 and 7 are pretty much it. So what are we going to try in there?
Times
Positive 3 and negative 7. So if we check that on the outside, 7 times x times negative 7 is negative 7x. And on the inside, 3 times x is positive 3x. That gives us negative 4x. Doesn't work, does it? If we switch it, it'd give us a positive 4x. Is that what we want? No. This one can't be factored. Yeah. How many of you got hung up on that and didn't even get to the second one? Okay. On the second one, I'll give you another example here in just a second. On the second one, what do we have to do? Common factor. What's the common factor going to be for the numbers? There's a bigger one than 3. 6. There we go. 6 divides into both of them. If you're ever really stuck, you can always factor them. 18 is 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. They both have a 2 and a 3. So 2 times 3 makes 6 is the common factor. Yeah. So we've got the 6. How about for the variable? Does x appear in both digits? Yep. And its lowest power is 3. How about y? Yep, y is in both digits and its lowest power is just y. So now I have to divide by 6, x to the third y. 18 divided by 6? Careful. 3. You're doing fine. 3, x to the 1 or just x. Y divides out. Negative 24 divided by 6. Negative 4, x to the third divided by x to the third cancels out. Y squared. Perfect. I'm going to give you one more set of those. There was no answer. Can't be factored. Make sure I got one that actually comes out here. Okay, give those two a shot. So for the first one, really hoping there's a common factor there. 15 for the number. How about for x? X to the third is the smallest power. Y? Y squared. Z? No z. There's a z in the first two digits, but not in the last one. So z cannot be in our common factor. So we're going to divide this by 15x to the third y squared. 60 divided by 15 is 4. X to the fourth. Y divides out. Z to the third. Negative 45 divided by 15. Negative 3x squared. Y. Careful. 4 divided by 2. No, 4 minus 2 is going to be 2. Y squared. And z. Just z. 75 divided by 15. Positive 5. X divides out y to the fourth. There it is. A little bit of a mouthful there. Now this one, it's not just x squared up front anymore. It's 2x squared. So that means we have to have 2x times x for that first digit, because it multiplies to make 2x squared. Okay, one's got to be positive and one's got to be negative. because this is a negative 12. Options for 12 are 1 and 12, 2 and 6, 3 and 4. Anybody get one of those to work? 3 and 4. Now here, because this is a 2 and this is an x, it does matter which one goes where. Plus 3 minus 4. So let's check it. 2x times 4 is 8x. Negative 8x, so it's 2x times negative 4. 3 times x is positive 3x. That adds up to negative 5x, which is what we want. So that does factor into 2x plus 3 times x minus 4. You got that deer in the headlight look, so.
I don't think I'll ever understand it. That's okay. Because I'm also forgetting about common factors. Like I'm doing the lowest. Like for the long one and number 5, I did 5.
Oh, you're doing a smaller factor instead of trying to find the largest number. Yeah, it's the lowest power of the variable, but it's the largest number for the coefficients. Okay. On to our new stuff for tonight. We have been solving equations and stuff and adding things to it as we go. We have had equations like 8x minus 7 equals 3x plus 23. And when we saw something like that, what did we have to do to solve it? We have to solve for x, but first thing we got to do is combine things, reduce things if we can or if we have to. And on this one, what do we see that we have to reduce? Perfect. There's an x on each side. We have to get rid of one. And as you said, the smaller one's the one we're going to get rid of, so we're going to subtract 3x. So all that's left over here is 23. To take 3x from the other side, the only place we're going to take it from is the 8x. So 8x minus 3x is 5x. We still have the negative 7 there. Now we've combined all the other extra things. Now we can focus on just solving for x. In other words, taking the equation apart and seeing what x is when it's all by itself. So what do we have to get rid of first here? The 7, and we're going to get rid of it by adding 7. So that minus 7 is gone. This is 5x. Adding 7 on this side, 23 plus 7 is 30. Perfect. What's next? Divide by 5. Perfect. X equals 6. Good. And we could, if we were unsure, put 6 back in here for x and make sure we get the same value on each side. And we will. I'll let you guys do that if you want to. So tonight we're going to run into things like this. Whenever we see parentheses, of course, it should scream at us. Do something here first. In this case, is there something to do there? Yes, there is. Can we combine anything inside the parentheses? No, there's nothing to do inside the parentheses. But there is something that we can do to the parentheses, which is distribute. Multiply by the 5. So 5 times the 3x is 15x. 5 times the negative 7, negative 35, plus 25. Now what? We're going to add 35. It's the same as any of the others we've looked at. Add 35, 15x equals 25 plus 35 is 60. And then divide by 15. X equals 4. And as always, we can go back and check it. If I put 4 in here for x, this is 5 times 3 times 4 minus 7. Check to see if that's 25. 3 times 4 is 12 minus 7 is 5. 5 times 5 is 25. So yes, we do get the same value on each side. So that is a correct answer. In your notes, try this one. So we see the parentheses screaming at us to do something there first. Anything to do in the parentheses? No. To the parentheses? Yes. Times 8. So 8 times 2x? 16x. 8 times negative 7? Negative 56. Then what? We're going to add 56. 24 plus 56 is 80. 16x equals 80, so we're going to divide by 16. So you get x equals 5. How have you had x equals 5? Good. Well, we can complicate these a little bit. That's kind of what I do. By doing something like this. A lot of people will ask me, in a problem like this, could I just divide by the 8 first and make this 2x minus 7 equals 3? Yeah, in this particular occasion, you could do that and you'll get the same answer. But there are some cases where you can't. This is one of those. I cannot just divide by the 5 here. So we're working on the parentheses. Is there anything I can do inside the parentheses? No. To the parentheses? Yes, times 5. So 5 times 3x is 15x. 5 times 1 plus 5. Now we still have this plus 2x out here outside the parentheses. What else can we do before we start to solve? Perfect. Combine 15x and 2x, which makes 17x plus 5 equals 56. Now we can start to solve. So what are we going to do first? Minus 5. So we subtract 5. It's 17x equals 51. And then divide by 17. X equals 3. Perfect. Any questions? Okay, I want you guys to try one in your notes. Try that one quick. So starting with the parentheses, there's nothing to do inside the parentheses. So we're going to multiply by the 5. 5 times 7x, 35x, and 5 times negative 4, negative 20. I do have plus 5 there. Are we ready to start solving? Not yet. What do we have to combine? Negative 20 and 5 make negative 15. And we still have the 35x here. Now what? Now we can start to solve by adding 15. Yep, it's subtracted, so you're going to add it. Yep. So 35x equals 105. That's one of the most common mistakes I see in these is you rewrite them, you change the sign on something. So it becomes plus, and now you're going to subtract it instead of adding it. So then our last thing, we got to divide by 35. So x equals 3. How many of you came up with x equals 3? Good. This one here looks kind of unassuming, looks very similar to the ones we just did, but it's actually a lot more difficult. What makes it more difficult is partly because it doesn't look any more difficult. This one here, we have those parentheses, and at first glance, it might seem like there's nothing to do for the parentheses. But there's a very important thing that needs to be done. There's a minus sign in front of the parentheses, which means the whole parentheses is negative. Well, how do we do that? The simplest way to deal with that is make that a -1 times the parentheses. So now we're going to multiply that parentheses by the -1. So we've got our 2x up front. That's not going to change. -1 times 5x is -5x. -1 times 1 is -1. Equals 14 over here. And on the left side, what are we going to do next? We're going to combine 2x and -5x make, careful, -3x minus 1 equals 14. And then add 1. -3x equals 15. And then divide by a -3. X equals 15 divided by -3 is a -5. Give that one a shot in your notes. Okay, so what do we do with the parentheses? -1. So the 21 up front doesn't change. -1 times 2x, -2x. -1 times 3, -3 equals 10. Then what? So we can combine the 21 and the -3. Perfect. So the -2x doesn't change. 21 and -3 becomes positive 18. It really doesn't matter. I could have had 18 minus 2x equals... Yep, that would be fine. I don't know why I put 18 over there. Good call. Equals 10. You're right. I don't know why I put the 18 over there.
So that does not change the answer.
This does not change, no. Nothing changed. That was my fault. So all we did there, yes, we combined the 21 and the -3 to make 18 here. Now what do? Now we subtract 18. So -2x equals 10 minus 18 is -8. And then divide by -2. X equals 4. Not so bad? I just want to see how you do on this one. Give this one a shot in your notes and see how it goes. Okay, so for our first parentheses, now we do work left to right still, just like we would order of operations. So our first parentheses, we're going to multiply by the 2. 2 times 5x, 10x, 2 times -4, -8. What do we have to do with the second set of parentheses? That's a -1 multiplying it. Perfect. -1 times 3x is -3x. -1 times 2, -2. That still equals 4. Now what can we combine on the left side? 10x and -3x make 7x. Anything else? -8, -2 make -10. And then add 10. 7x equals 14. And then this we divide by 7, get x equals 2. Anybody have that one right? Cool. Any questions? Okay. Well, as we saw there, we can throw in that second parentheses on the same side, or we can do it like this. We have a second parentheses, but it's on the other side. Still going to work pretty much the same way. When we're dealing with these equations, we can work with one side at a time if we want. So we can simplify everything that's on the left side first, then go ahead and simplify what's on the right side, and then we can start solving the equation. So on the left side, what's the first thing I would need to do? 7 times the parentheses, yes. 7 times 2x, 14x, and 7 times 5. Positive 35. What else is over there? Minus 4x. Now before we move over to the other side, is there anything else we need to do over here? Yeah, 14x and negative 4x make 10x plus 35. Now we have combined everything we can combine on that left side of the equation. On the right side of the equation, what can we do? 5 times the parentheses, 5 times 6x, 30x, 5 times negative 3, negative 15. And of course, we still have the plus 4 there. Anything else we can do on the right side? We can combine negative 15 and 4. So the 30x don't change. Negative 15 and 4 makes negative 11. Now we've done everything we can on each side. Is there anything else we have to do before we start to solve? We're going to have to get rid of one of them because we have an x on both sides. So we'll subtract the 10x. So 35 equals 30 minus 10 is 20x minus 11. Then we can add 11. Now we're starting to solve. Add 11. So 46 equals 20x. And then divide by 20. So either 2.3 equals x if you wanted it as a decimal. What if we wanted this answer left as a fraction? If I'd asked to leave the answer as a fraction. Well, go ahead. No? I can treat division, remember, as a fraction. I mean, this actually even looks like a fraction because I can put division into a fraction notation. 46 divided by 20 can be treated as 46/20ths. So I can either reduce it by dividing the top and bottom by the same number, or I can make it a mixed number and then reduce it later. Both of those can be divided by 2, so I'm just going to go ahead and do that. 46 divided by 2 is 23. 20 divided by 2 is 10. Well, 10 goes into 23 twice, with how much left over? 3 tenths. So 2 and 3 tenths, or 2.3 is also 2 and 3 tenths. But I can have the answer in either form. Any questions? Okay. Well, I'm going to have you guys try one of those. Give that one a shot in your notes. Where are we going to start? On the left side, multiplying the parentheses by 5. So 5 times 3x is 15x. 5 times negative 1, negative 5. We got plus 5 here. Anything else we can combine there? So negative 5 and positive 5 cancel out. We just have 15x here. On the other side, what can we do? 2 times 4x is 8x. 2 times 8 is 16. Still got the plus 3x, so what can we combine there? 8x and 3x make 11x plus 16. So now we got to get rid of one of the x's. So we're going to subtract 11x. So 15x minus 11x is 4x equals 16, and then divide by 4. X equals 4. What do you think? What's that? Much better than factoring? Okay. Let's have you try one more and then we'll take a break. See what you get for that one quick. So where are we going to start? Left side. We got 2 sets of parentheses. We're going to go left to right. 2 times 5x, 10x. 2 times negative 3, negative 6. Next is 6 times this parentheses. 6 times 3x, 18x, and 6 times 1. 6. There's nothing to do on the right side, so I'm just going to fill in the 56 as we go down. On the left side, what else do I have to do? Combine 10 and 18, 28x. Negative 6 and 6 disappear. So that's 28x equals 56. Divide by 28. X is equal to. Okay, with that, let's go ahead and take our break. We'll come back about 4:29 and we'll start with our second half.